Hey everyone, let's spend a few minutes discussing the transpose of a matrix. The transpose of a matrix is when we switch effectively the rows and the columns. So we replace entries Aij with Aji. So for example, the transpose of this matrix is that matrix. Note that this row became this column. This row became this column. This row became that column. Or equivalently, you could have said this column became this row, that column became that row. However you want to look at it, it's fine. Okay. So for example, the transposes of the matrices in example 2, well, if we take a look at those, then we see that it's going to be, first one is, I think it was 6, negative 8, 2 was that? No, 10. 2, 1, 3. See how I wrote the rows as columns? And let's find the transpose of this matrix, right? So it's going to be, first row is 6, 2, 1. And then the second row is what? Negative 8, 1, 0. Okay. And if we multiply this out, right, let's do this really quickly, since we have them. So this is, right, call this guy maybe A transpose, and the other guy is maybe B transpose. Okay, take a look at that. We're going to get, so that'll be 36 plus negative 16, right? This times this plus this times this, right? So 36 minus 16, I think it's 20. Then the second row will be 6 times 2 plus 2 times 1. I think that's 14. And then 6 times 1, it's going to be 6. All right, so just to be clear, the way I got those, right, I did this guy times this guy, then this guy times this guy, then this guy times this guy. So I got those 3 entries. Okay, anyway, now I'm going to do this for this row times each of those 3 columns, right? So I get negative 56, negative 16, and negative 15, and negative 8. And then I think we have 10 times 6 minus 24. I think it's 36. 10 times 2 was that. I think that's 23. And then lastly, I think we have 10. So now, so we have that. Okay, that's interesting to note. So let's decide whether these things are true or false. The transpose of a matrix. Well, if you think about it, if you flip a matrix diagonally, so to speak, or flip it, exchange the rows of the columns, and then do it again, you get back where you started. So that's true. You can try it out, but transposing works well with addition. So that's true. Multiplication, if you try it out, the transpose, let's take a look at this, right? When we multiply those 2 matrices, we got 30, negative 56, 17, 15. So let's write that out. In our example, AB transpose equals the matrix, what was that? 30, negative 56. It equals the transpose of this matrix, which is, so note that the diagonals always stay the same, the transpose of a matrix, but that's, like, the corners switch, like, everything else switches, right? Everything else flip-flops, right? That is not the same as this matrix, right? These 2 things are clearly not the same. So no, that's not true. Now, it turns out what is true is that transposing is, so to speak, anti-commutative. AB transpose equals B transpose A transpose. So, if you wanted to get this matrix right here, transpose do this matrix times this matrix, and we would have gotten it. So I'll leave that for an exercise for you to do. So I will say this, right? B transpose A transpose. I'll write this out super quick, and that'll be the end. That's going to equal this guy times 6, -8, 10, 2, 1, 3 equals that.